We're going to start looking at exponents and bases. People sometimes call exponents powers. That's not the perfect use of it. You can use it through much of what we do in this course. But when you get to Math 136, you'll start to see that a power is actually only a part of the exponent that goes along with another part of the exponent, which is called the index. So if I use interchangeably power and exponent in this course, that is not going to be something you can take all the way to the proper closure of Math 136. But when you're used to a power and have never heard of an exponent, let's say that an exponent is very much like a power. And here's what we've got. An exponent is called a power because it tells how strongly. When you're strong, you have power. So what's happening is when you have a power, it's going to tell you how strong to do something. How strongly to do what? To use its base as a factor. And factors are multiplied. We have terms are added, factors are multiplied. So when we're going to say part of what we're multiplying will be a factor, we're going to take our base and use it maybe more than once, because we're going to want to use it in a powerful way. We'll use it 2, 3, or 4 times with a power of 2 or a power of 3 or a power of 4. But it's for multiplying, so you don't just get to multiply them together and say, oh, that's what it is. I also don't like using 2's for this, because 2 times 2 is 4. 2 plus 2 is 4. 2 to the second power is 4. If I use a lot of 2's, you might learn the wrong thing and develop bad habits. So I don't want to use 2's all over the place. I will get us started with this. 3 is regular size. 2 is right behind it, smaller and elevated. And that equals something. Now I'm going to change their colors. But what we have there is 3 squared, or 3 to the power 2, is equal to 9, not 6. Because we're not using 3 twice for adding. We're using 3 twice for multiplying. So now, what I want to do is get my base to be what I start with. So since I start with that, let's go with the green. Let me put this in red. The exponent is our power right now, but really it's in the position of the exponent, and it's telling you how strongly. We're looking at using 3's. How many 3's are we using? 2. Because of the elevated and smaller size use of the 2, that is not 32, it is not 3 times 2, it's let's use 3's, let's use them twice. Why did that make 9? Because I'm going to show you both of the 3's. And I'm not adding them to get 6. I multiply 3 times 3 and I get 9. 3 here is the base. And the base is what we start with. Think of the term basis. The basis of an argument would be what you start the argument with. What's going on at the core of your numbers. We have a base 3. When you get into the heavier duty stuff, you might call it the root at some ways, or the root level of a computer program, or the root of all evil. All these things are kind of similar to the base. The base we're having here, though, is a 3. It's our multiplier. 2 is our exponent. And it has a couple features. It's written small, so it's a small sized writing. It's elevated. And very important here, it's right behind its base. Literally R-I-G-H-T, like to the right. It's not left, it's to the right, and it's behind it. It's the next thing that comes after it. More importantly, if you find an exponent, you can look down and to the left to see a larger written base. Or maybe you'll see parentheses there because it's taking the power of those parentheses. What I call 9 is the result. Of this exponential value. 9 is the result because if we have 3's, that's what the green tells us. If we have 2 of them, that's what the red power tells me. I have them being multiplied because of where the 2 is sitting. So I have 2 3's, 3 times 3, because it's an exponent, and it gets me the result of 9. So now what I want to do is set up several of these things. I want to set up 2 with an elevated 3 behind it. I want to set up 3 with an elevated 2 behind it. And for some strange reason to some people, I'm going to use blue to draw this dash. Now I'm going to want to do this. I'm going to want to do -3 and behind it elevated and written small, I want to put my 2. And it's probably worth it to have me do this. 2 to the power 3. There are no there are no parentheses on that one. I'll put a blue dash in front of my 2, which is raised to the power 3. And then one more thing that I'd like to do is put in a pair of parentheses with a dash and a 2 both inside the parentheses, and I want that to be to the power 3. And what this is trying to do is to really drive home the point that the exponent is written small and elevated, and it's right behind its base. And the key to remember about that is if you have parentheses, everything in the parentheses is stuck together. So when we have parentheses around a number like that, -3, that pair of parentheses contains -3. When we have parentheses around -2, that pair of parentheses contains -2. But now in the class I ask people to think about this. No threat when I ask you, 3 is my power, what is my base? And the base is 2, right? So here we go. I'm going to come across and I'm going to ask, what's the power and what's the base of each one? Power equals in each case. And you have lined paper, so it's a little easier for you to keep it neat. And some people think that some of them are tricky, as in I'm trying to fool you. No, I'm trying to make you aware. Now, I'm going to ask for what the base is by asking it in the long form of what is immediately in front of the power. But let's run down the powers. That power is 3, that power is 2, that power is 2, that power is 3, that power is 3. We're going to want to get a result for each one also. Result is both a digit and a sign that may be in front of it or a sign that we don't write. If it's positive, we don't say positive all the time. We can just say 2 when we mean +2, but if we mean -2, we must write and say the negative that's there. All right, so the powers are done. The power of 3, power of 2, power of 2, power of 3, power of 3. And I would ask the class normally to help me find that. Now, what we say is the base is what's immediately in front of the power. So the base here, no sweat, 2. What's the base here? What's immediately in front of the power here? I'll give you more of a clue because a lot of people think it's -3 and that's incorrect. What's the power here? What's immediately in front of the 2? And that base is 3. Now a hand shooting up in the back of the room? Yes? Oh, you think it's -3? No, it's not -3. Let me tell you why. See how far away that negative is that you called -3? It's not stuck on the -3. That is taking the opposite of whatever we get when we have a couple 3's. The base here is just 3. Only 3 is what I should call it. It's only the 3 because the 3 is the only thing right in front of the 2. If we have parentheses, it lassos them together, and you get everything that's in that pair of parentheses to be your base. So let's look at this one. What's the base of that one, which is green, which is trapped, which is close together? Base on that one is -3. This is not called -3 squared. This is a -3 getting squared, or -3 twice. I'll say the word squared because squares have the same size of the dimensions of up and down and across. They have 2 identical sides. A cube has 3 identical sides. And so we'll say the word squared to mean power 2, say the word cubed to mean the power 3, and then we run out of fancy words. But this is a squared 3, and then we take its opposite. This is a squared -3. The parentheses make the negative and the 3 both be what sits in front of the 2, because you don't say, I squared a parenthesis. You square the contents of the parenthesis, so that's negative and 3 both going at it every time. How about this one? Did you get it from a minute or two ago? That it's not -2? Oh, I understand. Someone's still confused. What's immediately in front of the 3 is a 2, not a pair of parentheses. So there are going to be 3 2's. There's just going to be one negative that sign or one dash in front of it, and the base on this is going to be 2. Now what's the base on this one? You don't have 3 of those parentheses. You have 3 times occurring the contents of the parenthesis, which are -2. So now you might say, oh, all right, parentheses make a difference. Yeah, that I believe. You say, wait, when you have parentheses, you worry, and when you don't, no, you don't try and get some like 4 to 8 different rules to memorize and have each one work. What's important is the one concept that we're working on. The base is right in front of our power, so we need that. And now we're going to go get some results from this thing. Let's see what happens when we go get 3 2's. We don't get 6. 2 times 2 times 2, 8. This one has a dash in front of 3's happening twice, not the dash happening twice. Therefore, there's a single dash in front of my 9. If you were to put this in your calculator, if you put in 3, then make it negative and square it, it'll get it wrong. Because you just told the calculator that this is -3, please give me 2 of them and get me the 9, and it'll be wrong. If you told the calculator, give me 3 times 3, when that's done, come back and put in the negative, you'll get it correct, because they're only a pair of 3's, single dash. How about this one? Parentheses are there twice. Each contains -3. That's double negative. 3 times 3, that is +9. 3 times 3 makes 9. The opposite of negative makes positive. We've got that. How about this one? Right here, we've got our base is 2. We have a single dash and 3 2's. Single dash, 2 times 2 times 2. Single dash, and then we got that thing making an 8. -8. How about this other one? 3 pairs of parentheses. 1, 2, 3 based on the power. Parentheses because that's what's going to contain a base that is every time a dash and a 2, dash and a 2, dash and a 2. 1, 2, 3 dashes. 2 times 2 times 2. That's an 8 of some kind. 3 dashes. This used to make me dizzy, remember? I would say that here I am on my number line facing positive, and I do every spin. I say, I want the opposite of negative, and then I give you that, right? And I'm facing negative. I had 3 moves that made me do it. I'm facing negative. Or if we look at it this way, those 2, all this stuff back here, except for the first dash, make 8. You get the 8 from that, you get the opposite of -8 with a dash in front of it. So you still have a dash. That's 3 negatives on the same term. It's an odd number, and that's going to make it be negative, and we're going to get 8. So now it's like, wait, how come that was -9 and that was 9, but then this was -8 and that was also -8? And you might be trying to learn a bunch of separate sort of rules to do that. The thing to do is to recognize what is your base, how many of them do you have, and what does that create? and take the time to do that with what you know instead of trying to memorize something, because my thoughts are things that you memorize are easily forgotten. Things you understand will stay with you for a longer time. So that's how we've got that going. And I have some similar stuff to work with here. Because we can substitute in values. If you're used to what I have you do when you substitute a value in, you bring the number in, and that number comes in parentheses. And that's awesome because it will take care of making sure that your negative doesn't look like minus, right? If I said I wanted negative 2 to be raised to the third power and I bring my parentheses, I can get this. There's 1 of them, there's 2 of them, there's 3 of them, and we got that. It was this, and it was this. If you do it without the parentheses, all right, maybe your dots are there, but they're a little small, or we miss them, and you blame the person for missing them. But it's easy to miss a dot, it's hard to miss the parentheses. If they miss those, that looks like negative 6. Wait, what? If that's what you truly meant to have me do, I'd have to put my plus signs in there, add up all the 2's together, get a 6, drawing on the negative all day long, and that's going to get it for you. Not because there's 3 negatives, but because these 2 work together to make 4 that's negative. 4 and 2 work together to make a 6 that's negative still. So the parentheses are a very big key to this. So when we're working on exponents and when we're working on bases, we have things like that to deal with. So I want us to evaluate these things. When x equals 2. Let's go with when x equals negative 2. Let's go right to the work that we have to do. We have negative 3x squared. We have negative 3x to the third. We have a dash in front of x to the third. And we have a dash in front of x squared. Then I have that same kind of looking thing, but what about if I have negative 3x and then the whole thing is squared? What if I have parentheses around negative 3x to the third and the whole thing is squared? What if I have parentheses around negative x and the whole thing is cubed? What if I have parentheses around dash x and then the whole thing is squared? How do they turn out? I went with 2, it's not too big. We got stuff going on here. What I'm going to do is turn my negative 2 into blue. Still negative 2. And I'm going to make you use it the way you should, which is anywhere it drops in, put it in with parentheses. So when you see parentheses around a negative 2, you just saw my x show up on the scene. So I'm going to draw a line here to separate those out. This is negative 3. In the parentheses is going to go my x. This is negative 3. In the parentheses is going to go my x. This is my negative sitting in front of. There's my x, and it's going to be cubed. And this is sitting parentheses in front of. There's where my x is going to go. It's going to be squared. Let's look at this one. I have parentheses negative 3. There's where my x is going to go, and that's going to be squared. Parentheses negative 3, that's going in there with a cubed value, and that's going to be squared. This is in parentheses, I have negative, and then I have my value for x, and then that's going to be cubed. And this is going to be my parentheses and negative, and here's where my value of x is going to go, and it's going to be squared. Now the smallest parentheses in each case are about to hold my negative 2. We got to find out what these do. They use order of operations. Order of operations says you want to do parentheses first until they're a single number. Every little parenthesis is a single number now, so we don't have to do that. Exponents, right? Exponents. P-E-M-P, then E, then M-D, then A-S. E is getting pretty high priority. Every pair of parentheses that's little now has the number negative 2 in it, so I don't have to deal with those parentheses at that level anymore. Let's see what we get. Negative 3 times negative 2 times negative 2. You get a value for that. This is negative 3 And then I have 3 of the negative 2's. Now from black, I have the dash, right? It could be -1, it could be dash, right? I mean, you might like it this way. And after the -1, I actually have -2 3 times. And back here, I have the dash, which can function as -1. And in this case, blue, I have -2 happening twice. Let's go see what each one makes. You got to determine if it's positive or negative. And we got to determine what the total value is generated by the digits. Okay. This has 3 dashes. And therefore now it's gonna be 3 times 2 for 6, 6 times 2 for 12. That's -12. This is not 8 things to memorize, but that's -12. Let's look at this guy. 1, 2, 3, 4 dashes. 1, 2, 3, 4 dashes. 3 times 2 is 6, times 2 is 12, 24. It's +24 with 4 dashes in front. It's the opposite of the opposite, so it's the same thing as the opposite of -24, and it gets me +24. This one, 1, 2, 3, 4 negative signs, 4 dashes. 1 times 2 times 2 times 2. So 1 times 2 is 2, times 2 is 4, times 2 is 8, +8. And how about this one? 1, 2, 3 dashes. 1 times 2 is 2, times 2 is 4, 3 dashes, -4. Okay, these are the values that we're working on when we drop in the x, including its parentheses in blue, to get it to happen. Now what happened here, on the ones to the right, we threw parentheses around everything before we took it to the second or third power. So what happens here? Inside the parentheses, we got a 3 times 2, which is 6, which is double negative, so it's positive. We get 6 squared and we get 36. Now this one's a little different. This one is -3 inside each parenthesis, and then we get -2 times -2 times -2. And that's still squared. 1, 2, 3, 4 parentheses, or 4 dashes in front of 6 times 2 for 12 times 2 for 24. See, so we got 3 2's in there. Right, 24 squared. That's positive. It's got 4 dashes. That's going to be positive. Get you 576. 24 times 24. Pretty big number. This one, each time the parentheses contain the opposite of -2, so each parenthesis contains a 2. So there 3 times. That's 8. Wait, that's the same as that? Work that way. And this one, each time, is going to have the opposite of -2, which is going to be 2 squared. 2 times 2 is 4. So what happened is the parentheses here jammed in the 3, so we got an extra 3 on that instead of getting 12. We got 36. I'm looking at digits only. But on this one, there was not an extra 3. Let's see, was there? Oh, on this one there was a lot of extra brought in. We brought in 3 extra 3's. We got to multiply that thing by 27. Or 2 extra 3's. Is it 9? No. We see that in this case, we had 3 2's and a single 3 for 24. Here, we had 3 2's and a 3 each time, twice. It's a big number, 576. And on this one, we had a single dash in front and 3 on the inside for 4. On this one, we had 2 dashes inside happening 3 times for 6, but that's also an even number, so 6 dashes or 4 dashes will make a positive. Each came around to be 8. This had a single dash in front and 2 from inside. This had a double inside, twice. That made 4. This made 3 of them. And you got your signs being different. So that's what we're going to look at. That's a big thing that happens early on, and a lot of people have trouble with those negative signs, the dashes. So that's what we got for this section.